I'm now going to lead us through a discovery of the number e. We're already familiar with the number pi. Pi is about 3.14, etc. So the number is represented with the Greek letter pi. We're going to learn a number that's represented with the letter e. In order to discover it, we're going to get our graphing calculators, and we're going to enter the following function. So go to your y equals, and we want to enter this function. We want to enter the sum, so enter parentheses, the sum of 1 plus 1 over x, that whole quantity raised to the x power. So don't forget the parentheses around here. Now we're going to change our table setup. We use the auto feature most often. For this discovery, I want you to arrow down and select ask instead. So hit enter to select ask instead of auto. Now when we go to the table, second graph, go to the table, it's empty. So instead of just generating the x values for us automatically, we're going to enter the x values. I would like you to enter the following x values. We'll start with 1, hit enter, 2, and enter, 10, 100, 1,000, 10,000, and then finally 100,000. So as we evaluate that function, 1 plus 1 over x to the x power, as these x values increase, so we can say as these x values are increasing infinitely or approaching infinity, the y values are not increasing infinitely. We can see that these y values are evening out at this number right around 2.718. That is the number e. So if we go back to our home screen, so if we hit second quit, the number e can be found as the second function of the division key. So if I hit second and the division button, there's the number e. We hit enter. There's that number, 2.718, etc., that we found here in the table as these x's got infinitely large. So that is the number e. Another way to get e from your calculator, the second function of this ln button, we'll learn more about the ln button in the next couple sections, but the second function of ln, so if I hit second ln, it gives us the e base, and then we can enter the exponent. So if we just want e to the first power, we just put a 1 here and hit enter. But if we wanted to evaluate a power of e, that's when this would be useful. So if I wanted to evaluate like e cubed, I'd close the parentheses here, enter the 3, and hit enter. So going back to our notes here, this LIM, this means limit. This is some new notation. This is actually calculus notation. But you're familiar with this arrow notation, meaning approaches. So the number e is the limit. This LIM means limit. As n approaches infinity, or here the x's, as they got infinitely large, as they approach infinity, as x approaches infinity, or in this case n, this quantity approaches the number e. So don't worry so much about this limit notation for now, but this idea of x is approaching infinity, so here x is approaching infinity, then our y value is approaching this number e. So that's all this is saying. So when we see the number e, we want to think, okay, it's approximately 2.7. So when we go down here to our parent functions, f of x equals e to the x, that's a parent exponential function. So this is just one of our parent exponential functions with a base, in this case, of e. So this is the parent exponential function because it's in that form a to the x power. But in this case, our a is the number e. So this is another way of saying approximately 2.7 to the x power. So when we want to list key points on any parent exponential function, we know our key points are going to be -1, 1 over a, and in this case that would be 1 over e, 0, 1, and then 1, it's the base a, in this case that's the number e, because if I plug in a 1 for my x here, e to the first power is just e. So here are my 3 key points. So we know that this e, this is approximately 2.7, so if you sketch it on your graph, you're going to sketch it between the 2 and the 3. Now 1 over e, if we enter that into the calculator, 1 divided by e, I can see that's approximately 0.4. So when you go to sketch this, you'll be able to approximate that 0.4, somewhere, about halfway between 0 and 1. Now we know all parent exponential functions have a horizontal asymptote of y equals 0, so this is no different. So here we can see this graph sketched. Here's the horizontal asymptote, y equals 0. My 3 key points, -1, 1 over e. So here's this 1 over e. This is this approximately 0.4. So you can see they plotted this y value is about halfway between 0 and 1. Here's our key point 0, 1. Here's our key point 1e, and when they sketch the e is again about between here, between the 2 and the 3, a little closer to the 3. They listed a couple extra points on here, but when you guys sketch this, you know you need these 3. You need these 3 key points of that parent function.